Here are the graphs for cosecant x, secant x, and cotangent x. Now, how are you going to remember how to draw them? They're actually quite simple if you already know sine x, cos x, and tan x. I'm going to start off by drawing the xy axes on our grid here with the same usual increments of pi over 2. So I'm going to start off by drawing the sine x graph because it's related to cosecant. Usually we would have a point at 0, 1. Okay, so we would start there, and usually our graph would look something like this. I'm writing some lightly in here because eventually we do want to get rid of this graph because it is not part of the secant graph, but it definitely helps us draw the graph. So the rule is if you want to use your sine graph to help you draw the secant graph or cosecant graph, you're going to have asymptotes at the zeros. So every time we cross the x-axis, this creates an asymptote. Okay, so that's where our asymptotes are. And there are points that are going to be the same. So every time you hit a max or min, that point is going to be there as well. So this is a maximum, this one's a minimum. And then from there, we can draw the arms. So if your graph is above the x-axis, this is going to go towards infinity. If it's below the x-axis, your arm's going to go below, so it'll be towards negative infinity. And you would follow the same pattern if you want to draw more than one period. So it looks something like this. So I did use my sine graph to help us draw this. Again, you don't want to include it, so I am going to erase this bit now because I don't, it's part of our graph. It's pretty important for you to get rid of it, but it can definitely help you draw the graph. So if you take a look at what I have drawn for y equals cosecant x, you can see that's very similar to the picture that I've shown you before. If you want to keep this in here, that's fine. Just write a note to yourself on the side that you must erase your sine x graph afterwards. So your characteristic for your cosecant graph, your domain is all x's except whenever we have x is equal to n pi, meaning every increment of pi, you're going to have an asymptote there. So here is our domain. X cannot be n pi, where n is an integer. Also, your range, you can tell that we can go from negative infinity to negative 1, and then 1 to infinity. And your period is 2 pi. This is what your period looks like from there to there. Or similarly, you can read it from here to here, which gives us a period of 2 pi. Moving on to our secant graph, you can do the same sort of thing. You can draw it in your cos x graph first, and then use it so you could actually draw the secant graph. So I'm going to draw a dotted line for where our cos x graph would be. It looks something like this. Something like that. The same sort of rules apply when you're trying to draw the secant graph using the cos graph. every time you cross the x-axis, that's where an asymptote is going to be created. And if you think about why is that, well, y equals 0 here, or cos x is equal to 0 there. So if you do the reciprocal of it, that'd be 1 over 0. And we can't have that, which is why we have an asymptote there. And then you're going to have points at the max and mins. And again, if you are above the x-axis, your arms are going to go towards infinity. If you're below the x-axis, your arms are going to go towards negative infinity. Looks something like that. Again, I'm going to write a note here. You should erase the cos x graph you used to help you draw the secant graph afterwards. That's not a part of the graph. Lastly, for cotangent, it's not the same sort of thing as sine x and cos x. You just had to remember this. But if you compare your cotangent x with the tan x graph, your shape is pretty similar. You still have asymptotes. Your asymptotes have shifted over. It's going to be at 0, pi, 2 pi, and so on. And now we have a decreasing function, or a decreasing function within those two asymptotes. That's going from positive infinity to negative infinity. Your period is still the same, your range is still the same, and your domain has changed because your asymptotes have changed. So let's practice drawing the cotangent x graph. So if we remember from the tan x graph, usually we would have asymptotes at pi over 2. Here we're going to have it at pi and 0 instead. So we're going to have an asymptote right at 0, at pi over 2, at pi, 2 pi, negative 2 pi. Then our zeros are going to be at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and in between our asymptotes we should have something that looks like it's decreasing. And again, our period here is going to be from a length of pi. If you just take a look at from 0 to pi, that is 1 full period, and then it repeats after that. So that is your y equals cotangent to x. If you want to compare the tan x, think of this. Arms are going to be, arms go the opposite way. In other words, they're decreasing. Or it looks like it's decreasing. And also asymptotes are moved over. So very similar to the time when I tried to teach you the tan x, the sin x, and the cos x graph. To practice your reciprocal graphs, reciprocal trig graphs, I want you to take out a piece of paper and draw these over and over and over again with all their characteristics and properties, so that they are ingrained in your brain.